So for an energy example, let's consider that we have a 100 millihenry inductor. Let's make a list as we read it. L equals 100 millihenries times 10 to the minus 3 henries, whose windings have a resistance of 4 ohms. So the resistance associated with that inductor is 4 ohms. It's connected across a battery with a potential of 12 volts. And that battery has an internal resistance of 2 ohms. And internal resistance, hopefully you remember, it has a symbol of a lowercase r. How much energy is stored in the inductor? What is UL? So this is kind of a good question because it puts a few things together. It reminds us about internal resistance. We have to think a little bit about circuits, and we have to ask how it's going to apply to our inductors. So why don't we start with the equation of energy stored in an inductor. When we write down that equation, maybe we'll get an idea of where we need to go with this. So the energy stored in an inductor is equal to 1/2 times L times I squared. Okay, L is no problem, that was given. Well, what's I? So we should try and figure out what the current is. If we want to figure out the current, let's draw a circuit diagram. So in our circuit diagram, we've got our battery here, plus minus epsilon. It has an internal resistance, that's little r, and then that's connected to an inductor which has some resistance r. Ideal inductors, of course, don't have any resistance, but sometimes real ones do. Sometimes what we do for batteries with an internal resistance, sometimes we just put those in a box. So now if we want to find out the current in this circuit, what we can do is write Ohm's law. So there's a potential increase by the battery of epsilon, that's going to be 12 volts. There's a decrease across the internal resistance, minus I times R, and a decrease across the inductor due to the resistance of the wire in the inductor. So we can solve this for our current I. I is the potential over the combined resistance. So 12 volts divided by 2 ohms plus 4 ohms. So the current that flows through this circuit then is 2 amps. Now we're ready to come back to our inductance equation and find out what the energy stored in the inductor is. So we've got 1/2 times the inductance L, 100 times 10 to the minus 3 henries, times the current of 2 amps squared, gives us a stored energy of 0.200 joules. Okay, so that finds the energy in that one. I've got one more question here, and it's a similar sort of question, so I'm going to say you try it, although I will stick in the workings with these notes.